Hello again. So this packet will be talking about powers and roots and scientific notation. This will be from pages 24 to 31. So let's get started. Okay, this is technically packet 3. And we will be discussing at the end of this video, you should be able to understand and define the terms of a power, a root, a base, and an exponent. You should be able to calculate the value of a number raised to a power. You should be able to calculate the value when numbers with powers are added or subtracted together. You should be able to calculate the value when numbers with powers are multiplied or divided together. You should be able to simplify powers with like bases, calculate numbers with negative exponents, and convert very big or very small numbers into scientific notation or convert scientific notation into regular numbers. I know that sounds like a lot, but most of it is interconnected, and I think you'll be just fine. So let's begin. Let's start with a few definitions. So a power is the product, not the produce. Let me change that to the product. It is the product of a number multiplied by itself one or more times. The base is the number being raised to the power, and the exponent is the number of times the base is being multiplied by itself. And the key word here is itself. A lot of people make mistakes when you talk about powers. So let's give an example here. So if I had the 3 to the second power, we have the base. Put that right here. The base is the number that is being raised to the power. The exponent is the little number up here. It tells how many times you're multiplying the base by itself. So that is your exponent. And the power is basically the answer to that problem. So 3 to the 2 is really 3 times 3. Never, never, never say 3 times 2, because you're going to get a whole different answer. It's the base multiplied by itself twice, or 2 times. So 3 times 3 is 9. So the answer, the power, is 9. 3 to the second power is 9. Okay? Try this one. Let's clear this. Try 4 to the third power. What would that be? Well, it would be 4 times 4 times another 4. Right. So how would we figure that out? So we have 4 times 4 is 16. And then 16 times another 4. What is 16 times 4? Whoops. 16 times 4. 4 times 6 is 4. Carry the 2. 16 and 4. Do it this way, in case you're wondering. 24. Carry the 2. What do you get? 64, right? So 16 times 4 is 64. So 4 to the third power then is equal to 64. So far, so good. See if I want to go to, we'll go to the special rules in a minute. So what I'd like to do now is pull up your packet. If you want to get your packet out, I'm going to be working from page 25 to start with, and I'll have it on the screen, but you'll want to have it with you. So see you in a moment. Okay, page 25. I'm going to be doing this chart with you a little bit. I'm not going to do the whole chart. So let's take a look at some of these. I want to do number 1 is done for you. So the product of -1 times -1 written as a power is -1 to the second power. In words, it would be -1 to the second power, or you could say -1 squared. So let's do the next one. We have +5 times +5. So that would be 5 to the second power. I don't know how to make a second power. I think I'm going to have to write this. let's write. Oh, I don't do that. How did that happen? Clear my drums. Okay. We want to do 5 to the second power. There we go. And in words that I can type, that would be 5 to the second power, or 5 squared. There we go. Myself down here. Okay, next one is 1/2 times 1/2. That would be 1/2 to the second power. In words, that would be 1/2 to the second power, or 1/2 squared. Okay, so far so good. Next one, 6 times 6. You want to pause the video and do it ahead of me? Go ahead and then see if we got it right. It would be 6 to the second power. And in terms of words, it would be 6 to the second power, or 6 squared. I want to fix the other one here too. It stretches out further and it fits in the column better. Okay, so far so good. Let's look at number 6. What is that? -3, -3, -3. That would be -3 to the, how many? Third power. Yes. And in words, it would be, make it bigger right away here, -3 to the third power, or -3 cubed, right? Cubed is another way of saying something to the third power. Okay, let's do number 8. -3/4, -3/4, -3/4. That would be -3/4. It's a bad 3. I'll fix that. -3/4 to the third power. Right, and that's exactly how you would put that in words. -3/4 to the third power, or -3/4 cubed. Yeah, very good. And I wanted to look at number 12. So if you need to pause the video and get this written down, go ahead, and then I'm going to scroll up. Number 12. Okay, how does that one work? We got 1/4, 1/4, 1/4, and 1/4. How are you going to do this? Yep, 1/4 to the fourth power. So that would be 1/4 to the fourth power. I don't know if you could say, you say to the third it's quadruple, or it's cubed. I don't know if you could say quadrupled. 1/4 to the quadrupled, or quadrupled, maybe, but normally you just say that. So that would be 12. Let's look at row 15. So I'm clear this now and scroll up again. Row 15 here, draw a line under it. I'm going to do this row right here. Here we go. So find the value of each power. 2/3 to the second power. That is the same as, change colors here. That's the same as 2/3 times, I'm going to put a little dot for times, that means times. 2/3 times 2/3. 2/3 times 2/3, you multiply across the top. 4. You multiply across the bottom, 9. 4 ninths. 4 ninths is the value of that power. Okay, negative 4/5 to the, I think that looks like, I think my copy is better than the computer's, to the third power. So this is a little 3 right here. This is a 3. Can't tell that. So negative 4/5 to the third power is negative 4/5. Now be careful because you got to use your rules for negatives, right? Multiplying negatives times negative 4/5 times, again, a third one, right? Times negative 4/5. And remember a couple of things now. So how do I do this? I have 4/5 times 4/5. First I do the first two. So this 4 times 4, that's going to be positive now because two negatives make a positive, right? Same sign, right? Makes a positive value. And on the bottom, 5 times 5 is 25. So now I have a positive 16/25, and I still have to multiply that by the remaining negative 4/5. So let's put that in there, negative 4/5. So 16 times 4 was 64, right? 4 times 6 is 4, yep. So that would be negative 64 because now I'm multiplying a positive times a negative. That's the top value. The bottom value would be 25 times 5. That would be 125. So the answer to this one is negative 64 over 125. So I could circle that so we can know what that is. Should I circle that? Maybe. So that is the answer to number 2. The next one is, I'll change colors again here, 1/2 to the 4th power. So it's 1/2, I believe it's to the 4th, let's double check it. Yep, 1/2 times 1/2 times 1/2 times 1/2. So what would that be? Well, the top would just be 1 times 1 times 1 times 1, right? What would the bottom be? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 1/16 would be the answer to that one. And I can go ahead and circle the one over here that I didn't. We'll circle all of them. Okay. And then the last one is 3/4 to the 3rd power. Yes, to the 3rd power. So we get 3/4 times 3/4 times 3/4. And what would that be? 3 times 3 is 9. 3 times 9 is 27 on top. And on the bottom, 4 times 4 is 16. 16 times 4 is 64. So that is the answer to that one. Go ahead and pause the video if you need to get this down, and I'm going to clear it then. And I want to talk about a couple of special powers. This will be on page 26 of your packet. So let me clear my drawings and let's bring up a little bit of notes again here for a moment. Okay. So special rules. Any number to the 1st power will be that number. And any number to the 0 power will always be 1. So for example, a better color here. If I have 3 to the 1st power, that answer would be 3. Yeah. If I had 1020 to the 1st power, I would get 1020. So any number to the 1st power is the number itself. It is the base. Now the second rule, any number to the 0 power is 1. So 3 to the 0 power is 1. 1020 to the 0 power is equal to 1. Right. 1 million, write that I suppose, 1 million, comma, 0, 0, 0. 1 million to the 0 power, supposed to be a 0, it's a bad 0. 1 million to the 0 power is equal to 1. So that's the special rules. Let's look at then page 26. I want to do row number 17. So let's bring that back up. Okay. And the rules are written here for you as well. You can go right ahead and read that and look at those examples on your own. So row 17 right here. Let's figure out some of these answers here. So we have 5 to the 0 power plus negative 3 to the 2nd power plus 4 to the 1st power. So let me just first of all highlight the rule that we're doing so you can see that we are doing this row right up here and this row all the way down here. So that helps you see it better. So 5 to the 0 power is what? 1. We just remember our special rule. Anything to the 0 power is 1. 1 plus, now we have negative 3 to the 2nd power. So that's negative 3 times negative 3, positive 9. And then we have 4 to the 1 power. What is any number to the 1 power? The number, right, 4. So we add that all up, we get 1 plus 9, that's 10. 10 plus 4 is 14. So that answer is 14. Let's look at the second one in the middle here. 4 to the 3rd power, that's 4 times 4, that's 16. 16 times another 4, that's going to be 64, minus 3 to the 2nd power. 3 to the 2nd power is 9, 3 times 3. And then plus 5 to the 0 power. Don't be tricked. It's really what? 1. So we're adding 64 and we're subtracting 9 and adding 1. So basically we're 64 minus 10. So 64 minus 10 is 54. Okay. The next one, negative 2 to the 3rd power, I believe. Yes, negative 2 to the 3rd power. So that's negative 2 times negative 2, which is a positive 4, times another negative 2. So it's negative 8 minus negative 3 to the 3rd power. So we have negative 3 times negative 3 times negative 3. The first two negative 3's will give you a 9, positive, times another negative 3 will give you a negative 27. Don't get tricked on this one. This one's a tricky one. And then 2 to the 1 power is just 2. Be careful on this one. So I have negative 8 minus a negative 27 plus 2. So that's the same as negative 8, change the minus to an addition, change the negative 27 to the opposite sign, becomes positive 27 plus 2. Okay, now what do you do? Well, we have a negative and two positive. Let's combine the positives. 27 plus 2, that's 29. So we have a negative 8 plus 29. What do we do when we have a number that's opposite signed when you're adding? The rule from the last video was we subtract. So 29 minus 8. 21. And is it going to be a positive 21 or a negative 21? You take the bigger absolute value number and take that sign. So this absolute value would be 8. This absolute value would be 29. So it's going to be a positive 21. So that answer is 21. Okay? They can get more complicated like that. Okay, I'm going to clear my drawings. And I would like to go on to the next page, 27, row number 3. So let's multiplying and dividing with powers. I want to do row 3. A couple of them have been done for you already. So this is the row that I want to do. Okay, the first one is done as an example for you. I'm going to just go on and do the second one. You can look at that one on your own. So 3 to the 4th power, we're going to solve that first. So that's the same as 3 times 3 times 3 times 3 on top. And on the bottom, we have 7 times 7, right? So that comes to 3 times 3 is 9. 3 times 9 is 27. 27 times 3. I'm going to do that like this. If I don't know it off the top of my head, I'm going to go and multiply it out vertically. 3 times 7 is 21. Carry the 2. 2 times 3 is 6, 7, 8, 81. So 81 on the top. And on the bottom, I get 49. 7 times 7 is 49. Now, do I want to leave it like that? No. I have an improper fraction. I have a bigger top number than my bottom number. So now I want to divide. So let's go ahead and divide 81 by 49. And 1 will go into 81, right? 149. 2 of them would be over. That would be almost 100. So this would be 81 minus the 49, because 49 times 1 is 49. I subtract. 8 becomes a 7. 11 minus 9 is 2. 7 minus 4 is 3. So that 33, or that's a 2. That 32 is going to come back up here and be the fraction that remains. 32 over 49. And I don't think you can reduce 32 over 49. Not that I can think of. So then the answer then, the official answer to this problem here is going to be 1 and 32 over 49. So that is the answer. And I'm going to get rid of this now because we need a little bit, erase some of my lines there. Okay, the last one here is negative 4 to the 3rd power and 2 to the 4th power. So negative 4 to the 3rd power is negative 4 times negative 4 times negative 4. And we should know that one pretty good now because we've done a few of these. 4 times 4 is 16, that's positive. Times the negative 4 is 64 negative. 64 negative on top. And on the bottom, we've got 2 to the 4th power. So that's 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. Now we have to change that. So let's change colors here and do our long division. You might already be able to see what's going to happen, right? How many 16s go into 64? Well, let's try 4 and see what happens. Just if you don't know off the top of your head, you can always check it out like this. So 4 times 6 is 24. Carry my 2. 4 times 1 is 4 plus 2 is 6. So there you go. So it's exactly 4. So the answer then is exactly 4 for that one. Too bad circle, but there you go. Okay, so far so good. Next I want to do row, well, I want to check out something here for a minute. Let's go back to this note sheet here and talk about multiplying or dividing with powers that are, I think that's what's coming up next. Yes, so if you have powers with the same bases, so for example, if you have 3 to the second power, and you're multiplying that by 3 to the fourth power, that is the same as, and let me show you why this works. That's the same as, let me grab a text box, 3 times 3, right, the first 2 3's, and then times 3 times 3 times 3 times 3. So a little space in between them all. Because you have 2 of them, you have 2 3's for this one, and you have 1, 2, 3, 4 3's with that one, right? So how many 3's do you have altogether? Altogether, you have 3 to the, count your 3's, 1, 2, 3, 4, 5, 6, 3 to the 6th power, right? So the shortcut for that is if you have multiplying numbers with the same base, with exponents, it's going to be 3 to the 2 plus 4 power. And you can see why that works, because you're just adding your 3's together, right? So the real answer then is 3 to the 6th power, which is what we got when we wrote it out. But this is the shortcut way to do it. Just wanted to show you the proof of that, okay? Now what about dividing? So we are going to erase and show you division. So if we had, for example, 7 to the 4th power divided by 7 to the 2nd power, here's why this works. This is the same as 7, I'm going to actually use the text box for that. This is the same as 7 times 7 times 7 times 7 on top, and then on the bottom it would be 7 times 7. And we could draw a line between it, means division. And then we can cancel some things out, can't we? This 7 will cross off with this 7. This 7 will cancel with this 7. And what am I left with? Oh, I apologize. What's my phone going off? That would be 7 times 7 on the top and nothing on the bottom, just 1 times 1, right? So those are gone. So it's just 7 times 7, or 7 to the 2nd power, right? 7 to the 2nd power. Now, let's see how this works when we use our rule, subtracting the exponents. So 7 to the 4th power divided by 7 to the 2nd power is really 7 to the 4th power minus the 2nd power. 7 to the 4 minus 2 power, which gives us 7 to the 2nd power. So that's the shortcut. So these rules here are the shortcuts. Multiplying same bases, add the exponents. Dividing the same bases, subtract the exponents. Okay, now let's go to our packet again. So this one is number, which one did I want to do? 27. We already do 27. I think it's 28. Yes, 28. So let's scroll down to 28. I'll open my packet here so I can see what you guys see. Okay, and I wanted to do row 3. There isn't a row 3. Yes, okay. All right, keep going. This explains all the stuff I just explained. Okay. Here we are. So let's do row 3. Row 3 here. Right there, and there, and there, and there. Okay, so we have 6 to the second power, 6 to the first power, 6 to the 0 power. That's the same as 6 to the, this one's done for you, 6 to the 2 plus 1 plus 0, 6 to the third power. So let's do the next one. 2 to the second power. So it's going to be 2 to the second power plus 2 to the third power plus the little 3 plus 2 to the 0 power is a 0. So it's good. The answer is going to be 2 to the fifth power. There you go. Next one, 8 to the third, 8 to the second, 8 to the second. Remember, the bases have to be the same in order to do this, right? 8 to the third. We're getting you ready for using letters at some point with algebra. So you got to learn these rules. 8 to the third, 3 plus 2, plus another 8 to the second. So that's going to become 8 to the 3, 4, 5, 6, 7. That's going to end up being 8 to the 7th power. Okay. Okay, let's try some of this with division. Clear that and scroll down just a little bit. All the way to row 8. Let's take a look at row 8. So we're going to be in this row right here. Just like that. Okay, so the first one's done for you. 6 to the 5th times 6 to the 4th is really 6 to the, what do they have there? 5. Plus, it should be 5 plus 2 times 4 to the second. Oh, I see what they're doing. 6 to the third times 4 to the second. So let's do the next one. That one's done for you. Oh, because 6 and 4 are not like bases. Did you notice that? So you cannot combine that. So let's do the like bases. We can only do the things that are alike. So that's what they did here. They only did these that are alike. So they did 6 to the 5 minus 2 times 4 to the 2. They couldn't do something together with the unlike bases. So this is as far as you can simplify it. So that's what we're going to have to do here. So we have a 10 to the 9th and a 10 to the 7th times the 5 to the 4th, right? So 10 to the 9th divided by 10 to the 7th is really 10 to the 9 minus 7, right? Because when you divide with exponents, you subtract the exponents. Make sure that the same base. So 10 to the 9 minus 7, and then we got times 5 to the 4th, different base. So if we simplify that out, we get 10 to the 2, right, times 5 to the 4th. And we don't have to actually calculate out what the value of that would be. We just have to simplify it. So we could. 10 times 10 is 100, and then 5 times 5 times 5 times 5, whatever that comes to. So next one, we have to look for similar bases. And I see that we have similar bases right, grab a different circle here, right here. And we also have similar bases right here, like that. So those are the ones we can use the rule on. So we have 9 to the 5th power divided by 9 to the 3rd power. So it's 9 to the 5 minus 3 power times 7 to the 6th divided by 7 to the 3rd is 7 to the 6th minus 3. So simplifying that, we get 9 to the 2nd power times 7 to the 3rd power. And that's as much as we can simplify it. So that is the answer to that one. Okay. Okay, now we're going to talk for a minute about negative exponents. So let's go down to the next page, 30, page 30. I guess it goes to 31 altogether. So negative exponents. And I want to, first of all, get a little bit of white space here for us to draw for a minute. And then I want to show you what a negative exponent is. So if you have 6 to the negative 2 power, that seems a little weird, right? All you do is reverse the 6 from the top of the number to the bottom, and you put it on the bottom of the fraction and make it 6 to the positive 2 on the bottom. So you just rewrite it. So then we can solve that, right? That becomes 1 over 6 to the second power is 36. So that would be the answer to that problem. What about 4 to the negative 2 power? What would that be? That would be 4 on the bottom of the fraction now, and make it a positive exponent, and it becomes 1 over 4 times 4, or 16, 1/16. So that's how you handle negative exponents. So let's take a look at this table here. We have, erase all this, and it says, what is the meaning of 7 to the negative 2, right? So they want us to rewrite it. 7 to the negative 2 is really 1 over 7 to the second power, like this. And in words, that would be 1, how would we say that? 7 times 7, 49th. 1/49th, right? 49th. There we go. 1/49th. And the value would be written as 1/49. 7 times 7 is 49. Okay. So I was just looking at the top, and what they really want us to write here is not 1 to 7 to the second power. They want us to write it out like this. 1 over 7 times 7. That's how they want us to write that out. And then they want us to write the wording differently. They don't want the value written. They want, so let's select that and fix that where they want it in the packet. They want to say that is 7 to the minus 2 power. That's what they want us to write there. And then the value is 1/49th. Okay? So let's try 10 to the negative 3. So we're going to write it out the way they want us to. That's really going to be 1 over 10 times 10 times 10. And again, the dot means times. And I'm going to extend my line all the way over. And maybe I should move my 1 so it's more in the middle. So 1 over 10 times 10 times 10. In words, that would be 10 to the minus 3 power. And what is the value of 10 to the minus 3 power? The value would be 1 over 10 times 10 times 10, or 1,000. 10 times 10 is 100, times another 10 is 1,000. So the answer is 1 over 1,000. Yeah. Okay, and the next one, 3 to the negative 4. I'm going to clear up some of these because it's kind of crunched here. Okay, 3 to the negative 4 is really 1 over 3 times 3 times 3 times 3. And in words, that would be 3 to the minus 4 power. And in value, it would be 1 over 3 times 3 is 9. 3 times 9 is 27. 27 times 3, I believe, was 81. I'm going to double check it. 27 times another 3 is 21, I think. 1 carry the 2, 6, 7, yeah, 81. Double checking. Okay, so that's how you fill things like that out with negative exponents. And all we have left now is scientific notation. So that's the last page of your packet, page 31. So clear my drawings and we're going to go to that. First, I want to give you some notes on that a little bit. So let's go back to this. So scientific notation, the first number must be written as a number between 1 and 9, and the second number is a power of 10. So let's give an example. I think your packet actually gives one here. Let's start by going this way. Let's write the number 750,000, the number they have in the packet, except they're going the other direction. I'm going to start by going and writing it in scientific notation first. So 750,000, how do I write that in scientific notation? Well, my first number has to be between 1 and 9. So I have to move my decimal. So there's an assumed decimal after a number to be at the end of the number. So there's my decimal now. But I need it to be in a spot where I get a number between 1 and 9. So if I keep moving it, 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, and I put it right here, I now have 7.5, and I could drop the zeros, right? So I can get rid of all those zeros, and I'm not going to actually get rid of them because I got to count something, but cross them off. So now 7.5 is between 1 and 9, isn't it? Yeah. So it's going to be 7.9, 5, I'm sorry, times 10 to the, I apologize for my family as I'm recording this, 10 to the, now we have to count, 1, 2, 3, 4, 5 spots, 10 to the 5th power. Where do I get the 5? Because I moved my decimal 5 spaces. 1, 2, 3, 4, 5 spaces. So 7.5 times 10 to the 5th power will give me 750,000. Okay, so that's how you write in scientific notation if you have a very large number. Now, what happens if you have a very small number? So I'm clear my drawings and let's try it the other way now. Let's say our number is 0.00075. Let's go with 75 again. I want to write this in scientific notation. Well, I have to have a number between 1 and 9, so I have to move my decimal until I get to that spot. 1, 2, 3, 4. So now I have 7.5. I could drop these other zeros, right? So 7.5 is between 1 and 9. So now my answer is 7.5 times 10 to the, let's count how many spaces we moved our decimal. 1, 2, 3, 4. 10 to the, now be careful. Now it's 10 to the negative 4 because we are having a very small number. So 10 to the negative 4 instead of 10 to the positive 4. Okay? Okay, I think we're ready. I'll clear my drawings. I think we're ready to try the packet now with that. So let's bring that back up. And we'll scroll back to scientific notation. You have examples there to look at as well. I want to do row 2, and then I want to try a few problems here. So let's end row 1. So I just want to try a couple of problems here. I want to leave some for you to do. So I want to do this problem right here. 8.75 times 10 to the 6. Now we want to write it in standard form. It's already been written in scientific notation, so we want to go the opposite direction, right? So when we do that, I'm going to write it out here just so we have it big for us. 8.75, and I have 10 to the 6, right? That little 6 means I have to move my decimal 6 places, and because it's a positive number, the 6 is positive, I'm going to move it to the right because my number has to get really big. 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots. My decimal is now going to be over here. And what do I do with my empty spaces? I fill them in with zeros. 0, 0, 0, and 0. And then if I need to add a comma, I can do that. So 1, 2, 3, comma, 1, 2, 3, comma. So the answer then to this problem is 8,750,000. So that is converting from scientific notation to standard form or to a regular number. And we could try the one right below it. So let's try this one right here. Underline that one right here. So if I was going to do that one, I have 8.5 times 10 to the negative 5. So let's write that out. I have 8.5, and that times 10 to the negative 5. If I have a negative exponent, I'm going to make a very small number, so I'm going to move to the left with my decimal. So my decimal starting here, it's going to go left 5 spots, because it's a negative 5 exponent. 1, 2, 3, 4, 5. My decimal is now over here. What do I fill in my spaces with? My empty spaces are going to be zeros. So the answer in standard form, that very small number then is 0.00085 for my answer. And that would be tens, hundreds, thousands, 10,000s, 100,000s, millions. That would be 85 millions. Yeah. Okay. And I'm going to clear that now. And let's look at row 3. We're going to use the positive exponent, write each number in scientific notation. So now this is what we practiced a minute ago. Let's look at the second one here, right here. So we have 30,000. We have to get a number between 1 and 9, right? So this is currently what it looks like. 3, 0, 0, 0, 0. And our decimal is currently after the number right here. We need to get a number between 1 and 9, so we got to move our decimal. 1, 2, 3, 4. Okay, now we got 3.0000. So 3 is between 1 and 9, so our answer is going to be 3 times 10 to the, how many spots did we move our decimal? How many jumps? 1, 2, 3, 4. 10 to the 4th power. Okay, so that's written in scientific notation for us. And I just want to point out one thing. Be careful when you're counting your jumps. You don't count this spot as a jump. You have to actually move and jump to count it as one. So this is 1 jump, 2 jumps, 3 jumps, 4 jumps. Don't say 1 before you've jumped. Okay, that can mess you up. Okay, row 4. Let's look at one of the other kind of examples here. Row 4. We got this middle one here. We'll look at that one. 0.0075. So we want to write that in scientific notation. So 0.0075. And we need a number between 1 and 9. So we know where our decimal is now. So we got to do some jumping to get it between 1 and 9. So 1, 2, 3. If I put the decimal right there now, I have 7.5, which is between 1 and 9. So my answer then is, right here, 7.5 times 10 to the, now this is the very small numbers, and I can't put that, I have to put that in handwriting here, to the negative 1, 2, 3. We went 3 jumps, so 10 to the negative 3. So 7.5 times 10 to the negative 3. Okay, so hopefully that gives you some help with this packet and that you'll be able to complete the rest on your own. And I will see you guys next time. Bye-bye. Have a good day.